AI models are amazing. What they know and how they can respond to any question you give it is nothing short of miraculous. But we are all still in search of a way to make them better, to know more, to sound like us, to do our work for us. But the model you download from Huggingface or the Ollama library is a general model designed to be really good for everyone. How can we tweak the model? Well, there are two main approaches we can take to modify what a model spits out. We can add new information in the prompt that the model can use to know things it didn't. Or we can tweak the model weights to change how the model responds, the style it uses. That tweaking is called fine-tuning. Fine-tuning isn't about teaching the model new information, although it is possible to do that. Instead, fine-tuning adjusts how the model will phrase what it says, the syntax it uses, the format of the output. But when you look online for tutorials on how to fine-tune, you get buried in code. It looks really hard. It's probably going to need an expert to perform all the steps. But it's not. It's actually pretty easy, though you definitely get better with practice. I think one of the biggest problems is that most folks seem to like to demonstrate fine-tuning using Python notebooks, which has to be the worst format for teaching. So let's take a look at how to fine-tune. I'm specifically using MLX this time around because it supports Apple Silicon, but in future videos, I'll take a look at Unsloth and maybe Axolotl as well. You might be shocked at how easy this is to do. Step 1. Come up with a dataset of questions and answers. Step 2. Run the fine-tuning process. And Step 3. Use the new adapter with a model. That's it. But Step 1 is definitely the hardest part, and the one most wrapped up in the dark arts that are hard to explain. But coming into this, I thought 2 and 3 were going to be the tough ones. And there's almost nothing to those steps. So let's start with Step 1. The goal here is to get the model to understand how you want it to answer certain questions, how to respond to a prompt, and so you need to provide a question and the answer in a format the model will understand. This is going to be specific to the model. Let's look at doing a fine-tune of Mistral. So the first step is to go to Ollama.com and find the Mistral model. Now click on the template. Now what I'm looking for is how the model expects to see a question and then the answer. This model accepts the new tool calling method with Ollama, but I don't really care about that for now. So at the end, there is an INST in square brackets, and then, if there's a system prompt, include it. And then include the user prompt. Then close that INST block. And then you have the answer. So now we need to replicate this a bunch of times. And we're going to save them in a JSON-L file. That's kind of like a regular JSON file, but not really. In JSON-L, each line is a new object. It's not an array of objects separated by commas, and I have no idea why. It certainly would be a whole lot easier for everyone involved if it was a simple array. But oh well. Now each object has a single key and value. The key is text and the value is the string we just talked about before with that INST block. So now think about what you want to train it on. You need to come up with at least 50 to 100 of these objects, and more can be better. And again, we aren't teaching the model new facts, but rather the style to respond with. Often folks want a model that will be able to write emails or documents as themselves, or at least a first draft of themselves. So that's what I'm going to try. If you've been here before, you know that I have a lot of videos, hundreds. And I have the scripts for most of the videos I've made in the last few years here on my Mac. And the way I talk in those videos is the same way I actually talk, and the way I write. So I'm going to read in the markdown files with those scripts, and then I'll split up each file by new lines. And then I'll get Ollama to summarize each paragraph. That summarization I have Ollama convert into an instruction for someone to write about. And there is my question. The original paragraph? That's my answer. This probably isn't an ideal example, but it seems to work somewhat well for this case. Now save 60% of the answers to the train.jsonl file, and then 20% to each of the other two files, valid.jsonl and test.jsonl. The fine-tuning process will need these. Now that we have that done, let's move on to step 2, run the fine-tuning process. Since I'm using MLX here, we need to install MLX LM. So pip install MLX LM. Next, we need to access the Mistral model on Huggingface. MLX needs the original safe tensor files. Apparently, you can also use quantized files, but they need to be in MLX's format, and I haven't found a way to convert the standard GGUF files that Ollama uses to that special format. The Mistral model requires you to log into Huggingface to download, so you need to install the Huggingface CLI and log in. Visit this page on huggingface.co to get that set up. Then run Huggingface CLI login to log into your account. Now we can get to the command to run to fine-tune. We start with the command mlx_lm.lora. Pass the train flag to tell it we want to do a fine-tune of the model. The model flag says which model we want to use. This should be org/model name. You can find this by going to the repo and clicking that copy button next to the name. The data flag points to the path where your JSON-L files are. The next flag is batch size. This tells MLX-LM how many examples are used in each iteration. You want this to be larger to go through everything faster, but larger requires more memory, so it takes some experimentation. Run that command, and now it's time to listen to the fans spin up. I have an M1 Max with 64 gigs of unified RAM, and it takes several minutes to run. But it's pretty much hands-off while it does its thing. When it's done, you have a new directory called adapters, and in there you'll find the safe tensors files and a config file. So now we need to define a new model using our adapter. Since we use Mistral, we can create a model file with from set to Mistral, an adapter set to the directory with our new adapters in it. Now Ollama create Mistral-f model file, and this will take a second or so. And now you can run Ollama run Mistral, and we can start using our fine-tune of Mistral. If you're on a much older version of Ollama, this may not work. Support for these adapters was added just in the last couple of days. Also, you need to create the adapter with the mlx_lm command. If you use the LoRa script in the MLX examples repo, it'll create an NPZ file, which needs to be fused to the original model, which is just a bit more of a hassle. MLX-LM creates an adapter that's used by Ollama natively. Is this a perfect fine-tune? No, not really. I have some work to do to make it better, but at least now I know it's not as scary as I thought it was. What do you think? Have you done any fine-tuning of models yourself? Any specific fine-tunes you think are really compelling? Do you have any ideas for a fine-tune you think you might like to do? Let me know in the comments below. Thanks so much for watching. Goodbye.